Good morning, my dear students. Today I will continue the problem number 21 in continuity. See the problem here. Read the question. The function f of x is equal to sin x divided by x plus cos x when x not equal to 0. K when x is equal to 0 is continuous at x equal to 0. Then what is the value of k? So it is already continuous. It means limit of f of x as x approaches to a is equal to f of a. Okay. So we have to check the continuity at x is equal to 0 only. At x is equal to 0, f of 0 is equal to constant. X equals 0, f of 0 is equal to constant. Now, I have to find limit of a function. Limit of f of x as x approaches to 0. So, no need to find left hand limit, right hand limit, because there is x not equal to 0. We do not break into conditions. We don't want break conditions. We can break x smaller than 0, more than 0, getting same answer. So no need here, directly we should do it. Limit of, so f of x is sin x divided by x plus cos x as x approaches to 0. Now we have to apply the limit directly. I could have written this number limit of sin x divided by x as x approaches to 0 plus limit of cos x as x approaches to 0. So this is the property. Limit of f of x plus f plus z is equal to limit of p of plus limit of z. As we know property, definition also we know, we proved one theorem result. Limit of sin x by x as x approaches to 0 is equal to 1 plus limit apply here cos 0. Cos 0 is equal to 1. So 1 plus 1 is equal to 2. We have limit of a function is equal to 2. Now since f is what? Continuous. Since f is continuous at x is equal to 0. This meaning limit of a function equal to, so this meaning I am writing limit of f of x as x approaches to 0 equals f of 0. Now equating f of 0 value and limit of a function. So what is the answer? 2 is equal to k. So what is the k value? K is equal to 2. So answer will be second option. Very clear concept this is. Are you okay? Very simple method. You can do it all questions in this way. You can get answers. Next problem. See the problem number 22. Have you taken this one? Second question. Read the function given by f of x is equal to tan x is discontinuous on the set. So where it is discontinuous, but tan x is a continuous at their domain. Where it is not defined. you can say very easily with graph. See here. So this is the coordinate system. X-axis, y-axis, horizontal. I have to take the coordinates. That means here. So on x-axis, real numbers like this I am taking. So this is negative numbers like this. So this is minus pi by 2. This is the pi by 2. This is the pi. At pi and minus pi by 2, I have to draw the lines parallel to y-axis. We know that tan of pi by 2 is undefined. Tan of minus pi by 2 is also undefined. So whenever you draw the graph smoothly, the graph is, so this is passing through horizontal also. This is the graph of tan x. If you take more points, so let us take, this is the 3 pi by 2. So again tan pi is 0, so the graph will be like this. So according to graph we are observing from minus pi by 2 to pi by 2 it is continuous. It is not defined at pi by 2 only and minus pi by 2 and at 3 pi by 2 and minus 3 pi by 2. It means what? At all multiples of pi by 2 it is not defined. So when it is not defined, at x is equal to multiples of odd multiples of pi by 2, that is 2n plus 1 of pi by 2 where n belongs to z. At these values tan x graph is undefined, is not defined. Is not defined. So at x equal to 2n plus 1 of pi by 2, tan x graph is not defined. So it is discontinuous at multiples of pi by 2 only. So it has so many number of points are there, number of discontinuity points are infinity. So number of points. So that is we can write 2n plus 1 of pi by 2, n belongs to n. At these values, tan x graph is not defined. We might accept these values, it is a defined, it is a continuous. Okay, the answer will be 2n plus 1 of pi by 2, n belongs to z. In the similar way, we can say that, okay. So we can say here, therefore, f is continuous at all real numbers, at all real values of x, except x is equal to 2n plus 1 of pi by 2 where n belongs to z. Okay, at all real values it is defined at x except x equal to 2n plus 1 of pi by 2. Very simple also. In the same manner we have doing cot. Cot where it is defined, where it is not defined important. Cot is not defined at multiples of pi only, n pi. So there it is a discontinuous. At x equal to n pi, cot x is not defined. So hence it is a discontinuous. So except that value, remaining all real numbers, it is a continuous. Sin x graph. Sin x is continuous for all real numbers, everywhere. Why? Because it is continuously drawn. Okay, it is defined at all real numbers. Cos x, it is also defined at all real numbers. So maximum limits are minus 1 to plus 1. In between these boundaries only it is oscillating. But tan of the here it is oscillating, but here not defined. Okay, same here also not defined. Not defined no? So at these values, at 3 pi by 2, at pi by 2 not defined. So like we See the next problem. Very important model this is for CV point of view. Greatest integer function model. The function f of x is equal to greatest integer of x, where greatest integer of x denotes greatest integer of function is continuous yet. So where it is continuous also. I will have explain method here. You can understand anything. Okay, one problem I will do that. For example, here integers are there, non-integers are there. What are the integers? 4 minus 2, 1. These are the integers. 1.5 is non-integer. Okay, firstly I am taking integer value. Let x is equal to integer. Any integer you can take. Let us take for example 4. This is the integer one. At x is equal to 4, I am taking f of 4 value. F of 4 is equal to greatest integer of 4 is equal to 4. For sake of understanding only I am taking. So here 4 nothing but a actually. Any number a. Okay, greatest integer of a also a leading. So you should imagine the number, any real number, any integer here. Now I am taking left hand limit, I am taking here, LH here. Limit of f of x as x approaches to 4 minus, a minus like this. This is equal to, I would have right, limit of f of 4 minus h as h tends to 0. Correct? 4 minus h as h tends to 0. This is equal to limit of, so smaller than or greater than, this function is the same. Limit of greatest integer of 4 minus h as h tends to 0. H is what? It is a small quantity. It lies between 0 and 1 only, very very small quantity. So again 4 minus h, something is subtracted means this value 3 point something only. Correct analysis? This is nothing but 3 point something. 3 point something only. So 3 point something this is. So greatest integer of 3 point something is what? That is equal to what? 3 only. Clear? So actually 4, one number less. 4 minus 1. Suppose if you take a, greatest integer of a minus h is equal to what happen? A minus 1 this is. General that is a minus 1. Okay, greatest integer value we got left hand limit is equal to 3. Similarly, right hand limit, observe that. Right hand limit. Limit of f of x as x approaches to 4 plus. I have to write this number. Limit of f of 4 plus h as h approaches to 0. Okay, this means function substitute here more than 4. Limit of 4 plus h as h tends to 0. This is what happened. H is a small number. 4 plus something. 4 plus something means what? 4.01 or 4.2, 4.3, whatever it is. 4 point something. So what is the greatest integer of 4 point something? This is equal to what happened? That is 4 only. Greatest integer of that is nothing but a. If you take a number, so this is also is equal to a only. So a minus 1, a simple number. So greatest integer of a minus h is equal to a minus 1. Greatest integer of a is equal to a only. A plus h is equal to a. Greatest integer of a equal to a. So we observe what? At integer, left hand limit exists, right hand limit exists, f of a also exists, but are not equal. are not equal to left hand limit not equal to right hand limit. So therefore left hand limit not equal to right hand limit. So what you say that is it a continuous at all integers? No. So f is discontinuous. Remember, f is discontinuous. F is discontinuous at x is equal to 4 that belongs to integer. So any integer you take, if you take any integer, it is a discontinuous always. So according to this, our options for first one not correct. Continuous asking, where it is continuous. So these three options are not satisfied. So might be the answer will be fourth one. Okay. Remember, greatest integer function is discontinuous at all integers. At all integers, whatever you take integer, it is discontinuous. If I take non-integer, now I have to show here. This is sake of understanding only. This much time no need to take. Okay, for sake of understanding, I have given 4 means any integer. Any integer A. Non-integer I am taking here. Same process at x is equal to non-integer, that is I am checking 1.5 which is non-integer only. Okay, 1.5 which is not integer, any real number that is. Now I have to follow one by one step. F of x is equal to greatest integer of 1.5. We know this is 1. It lies between 1 and 2. So small number is 1 here. Okay. So less number 1.5 that lies between 1 and 2 always. So what is the greatest integer is 1. In the same manner, I have to find the left hand limit here. Limit of f of x as x approaches to 1.5 minus. So left hand limit. This is equal to limit of f of 1.5 minus h as h tends to 0. Okay, this equals limit of greatest integer of 1.5 minus h as h tends to 0. H is what? A small quantity, very small quantity, negligible quantity. Suppose if you take 0.1 or 0.001, if I subtract 0.1 from 1.5, we get also 1 point something only. Here this is also nothing but 1 point something. Correct? What is the greatest integer of 1 point something? Is also is equal to 1. It lies between 1 and 2. So I got left hand limit is equal to 1 when it is not an integer. In the same way, I have to define right hand limit also. Limit of f of x as x approaches to 1.5 plus is equal to limit of f of 1.5 plus h as h tends to 0. This is equal to limit of greatest integer of 1.5 plus h as h approaches to 0. 1.5 plus h, what does it mean? This is, h is what? 0.1. Also 1.6. It lies between 1 and 2. What is the greatest integer of 1.5 plus h? Also will be 1. Now you observe that left hand limit exists, right hand limit exists, f of a also exists. Okay, this is f of 1.5 b. Clear? So f of a also exists. All will be getting equal. So what do you say then? It is continuous at x equal to 1.5. That means you should remember at x equal to non-integer This is our concept. Therefore, left hand limit is equal to right hand limit is equal to f of 1.5. F is continuous at x is equal to 1.5. So this is the difference between non-integer and integer form. If any integer given, remember for any integer, the function, greatest integer function is always discontinuous. Number of points of discontinuity is equal to undefined. Next thing, at any non-integer, the greatest function is always continuous. Number of continuity functions equal number of points of continuity functions also undefined. We constant. Okay, this is about greatest integer function model. Very clearly there, you should remember these things. Very important model. So most of the people they confused here. They are doing different methods. You do not worry. Very simple. Take one integer, take one non-integer. So the answer will be 1.5. So now in exam, given these model questions, you never check like this. For any integer given, it is discontinuous. For any non-integer given, it is continuous. Okay. Next question. So now I am going to the question number 24. See now what is the given problem. The number of points at which the function f of x is equal to 1 divided by x minus greatest integer of x is not continuous is. So here we have to find out discontinuous. Okay, we can take any integer. Just now we have seen that is you take the integer, find the number of discontinuities. Okay, shall we do it one more? Once again, take at x equal, just now we can say that at any integer or at any non-integer here. So discontinuous, when it is discontinuous, at integers. So number of points are undefined, so not defined here. So might be we can't say 1 point, 2 point, 3 point. So for all integers it is discontinuous. So answer directly we can say answer will be none of these, not defined. Okay, once again I will explain to you for sake of understanding. You take one integer, any integer. If you want to take here x is equal to, this is the integer. So limit value find out. Okay, first f of 2 find out. Any integer. F of 2 is equal to 1 divided by 2 minus greatest integer of 2. That is equal to 1 divided by 2 minus 2. This is here only not defined. F is not defined. So why should we go through the definition? No need to finding left hand limit, right hand limit. Hence it is not defined. So number of points here not defined. So number of points is not defined. Okay. So no need to check all this. Here only it is not defined. Yes, it is not defined at x equal to 2 only. Any integer. It is not defined means number of points of discontinuity, none of this. Next question. 25th question. See the problem. Let f of x is equal to mod of cos x. Then f is everywhere differentiable, but we are not seeing differentiable concept. Next we see. Second one, f is everywhere continuous but not differentiable at x is equal to n by. F is everywhere continuous but not differentiable at x is equal to 2n plus 1 of pi by 2. None like this one. So this is the graph of cos x like this. Okay, graph of mod cos x. So the cos x graph, it is continuous everywhere. This is the graph of only cos x here. Mod function means it always wherever it is above the x axis. Only mod of cos x like this. Only it becomes on the upside only. Mod of cos x. Also it is continuous graph. So like this with the mod of cos x graph, like this only comes here. Okay, it is a continuous graph everywhere. Is it a differentiable? So differentiable, how to check that? Limit of left hand derivative, right hand derivative. Limit of f of x plus h minus f of x divided by x. Generally, the cos function is not differentiable at all multiples of pi by 2. Cos 0x, if you take denominator 0 means it is not different. So differentiability in that chapter we have to see the same differentiable or not. But actually it is not a differentiable. So remember, it is continuous everywhere but not differentiable at all multiples of pi by 2. Cos 90 0. Okay, cos 370, 270 0 like this. It is not a multiples of pi by 2. It is not a differentiable at multiples of pi by 2. But every differentiable function is always continuous. So every continuous function may or may not be differentiable. So it is a continuous but not differentiable. Next problem. See the again mod x problems given. So what is the problem here? The function f of x is equal to mod of x plus mod of x minus 1. 4 options are given. Continuous at x equal to 0 as well as at x equal to 1. Continuous at x equal to 1 but not at x equal to 0, like 4 options are there. Okay, firstly we have to, whenever there is a mod function given, we have to break into cases using definition. As we know that mod of x is equal to plus x when x is more than or equal to 0, minus x when x is smaller than 0. Is it clear? We know all of these concepts, so I would have find the function here. So what is the f of x is equal to here? Mod of x plus mod of x minus 1. Now I am taking here if x is smaller than 0. When x is smaller than 0, f of x is equal to smaller than 0 means this is negative, this is also negative by definition. So negative 0 substitute, negative will come here. Smaller than any number we can take. So this is minus x, this is minus of x minus 1. Simplify, this is equal to minus x minus 2x plus 1. So when x is smaller than 0, function is minus 2x plus 1. Okay, smaller than 0, both are negative. You know all of the mod x definition. This is minus x plus x when x is smaller than 0, when x is more than or equal to 0. So according to definition, I break the condition. Next one, so here x equal to 1 also there. So between 0 and 1 observe. If interval x is less than or equal to between 0 and 1, it means what? More than 0, less than 1. Okay? When x is more than 0, mod x is always what? Positive number. When x is smaller than 1, this becomes what? Negative number. Minus of x minus 1. Now minus x plus x cancel, this is equal to 1. So between 0 and 1, 0 and 1, f of x is equal to 1 here. The next case, when is more than or equal to 1, then more than 1 means both are positive. Both are positive. Suppose if you take 2, mod of 2 is positive. Mod of 2 minus 1 is also positive. So that is f of x is equal to x plus x minus 1. This is equal to 2x minus 1. So these are the three conditions. So I break the condition like this. After the finding at all intervals, I get the function. Therefore, f of x is equal to, that is minus 2x plus 1 if x is smaller than 0, 1 if x is 0 and 1, that is 0 less than or equal to x less than 1, and then 2x minus 1 when x is more than or equal to 1. So this is the actual problem. He defines the whole function with modulus f of x equal to mod of x plus mod of x minus 1. Both are same. Now we have to check the continuity at x equal to 0, at x equal to 1. Sorry. So, at x is equal to 0, I have to check first. Okay, when x is equal to 0, this is x equal to 0 condition here. When x equal to 0, f of 0 is 1. F of 0 is equal to 1. Similarly, find the left hand limit. Left hand limit meaning what? Smaller than 0, that is limit of f of x as x approaches to 0 minus. Okay, this is equal to limit of f of 0 minus h as x tends to 0, as h tends to 0. When x is smaller than 0, this is the function. Okay, I substitute here. This is equal to limit of minus 2 bracket 0 minus h plus 1 as h tends to 0. Now you apply the limit. Put h is equal to 0. So this becomes only 0 here. 0 plus 1. 0 plus 1 is equal to 1. So I got left hand limit is equal to 1. In the same manner, we have to find right hand limit. So RH here. Limit of f of x as x tends to 0 plus, this is equal to limit of f of 0 plus h as h tends to 0. More than 0. When x is more than 0, this is more than 0 condition. f of x is equal to 1. So answer will be directly 1. Now we observe what? Left hand limit is equal to right hand limit is equal to f of 0 at x equal to 0. Hence f is continuous at x equal to 0. So continuous at x equal to 0. Now observe how many options are there. First option is there. Okay, fourth option is there. Maybe either first one or fourth one correct. So this is f is continuous at x is equal to 0. In the same manner, exactly similar, at x equal to 1, we have to do that. Now at x is equal to 1. At x is equal to 1, f of 1 find out. So that is exactly equal to 1. So when x is equal to 1, what is the f of 1 value? F of x value? 2x minus 1. Substitute x value 1. So 2 into 1 minus 1, this is also will be 2 minus 1, it will be 1. Now I have to find left hand limit at x equal to 1. Limit of f of x as x tends to 1 minus, I could have right limit of f of 1 minus h of f of 1 plus h as h tends to 0. When x is more than, when x is more than 1, f of x is equal to 2x minus 1. Substitute here, limit of 2 into 1 plus h minus 1 as h tends to 0. Now you apply the limit, put h equal to 0, 2 into 1 plus 0, that is 2 minus 1. 2 into 1 plus 0 minus 1, this is equal to minus 1, 1. Observe what now? Left hand limit is 1, right hand limit is 1, f of 1 also 1. So therefore, f is continuous at x equal to 1 also. So the function, given function mod x plus mod of x minus 1 is continuous at x equal to 0, at x is equal to 1. So check out the option number already, second, third, these are not correct because already we checked at x equal to 0. Now we have maybe either first one or fourth one. So fourth one also not satisfied, but it is continuous at both the values. So option will be first one. Clear? Next problem. Like this we are doing the questions. See the problem number 27. You can easily solve this question also. The value of k, which makes the function defined by f of x is equal to sin of 1 divided by x if x does not equal to 0, k if x is equal to 0 continuous at x equal to 0 is. So it is already continuous at x equal to 0. Okay, just we have to find limit of a function here. So at x equal to 0, what is the f of 0 is k has given. Next we have to find limit of f of x at x approaches to 0 as x approaches to 0. So what is the function given? Here no need to break the conditions, directly do always. Limit of sin of 1 divided by x as x approaches to 0. So if you apply the limit, it is what? Undefined variable, not defined. Actually, limit sin function is a finite quantity. It lies between minus 1 and plus 1. We can't define this. So actually, sin value, so my range is minus 1 and plus 1. Okay, so answer will be what? First one or second or third or fourth, none of this. We can't see it. So it is not defined. Next problem. See the problem number 28. Read the question. If f of x is equal to 2x and g of x is equal to x squared by 2 plus 1, then which of the following can be discontinuous function? We have the properties f of x is equal to 2x. It is a polynomial function, and also g of x is equal to x squared by 2 plus 1 is also polynomial function. So here what you say that both f and g are polynomial functions. We know all of you plus z is also continuous. So option number 1 is continuous. So this is continuous. Next property, f is continuous, g is continuous, then f minus g, subtraction is also continuous. So this is also continuous. And third one, f is continuous, g is continuous, and their product is also continuous. So this is also continuous. Fourth one, f is continuous, g is continuous, then g by f or f by z both are continuous, provided condition, provided f of x and g of x not equal to 0. But in this problem, he does not provide any condition. F of x not provided. So hence it is a discontinuous function. If he provided condition, if he provided this condition g of x or f of x not equal to 0, then it is a continuous. So which is the discontinuous here? So g of x y f of x is the discontinuous function. Why? Because he does not provide any condition here. If he provided any condition, suppose f of x not equal to 0, then it is a continuous. So discontinuous method. So by based on property, he explained, he has given one question. Very carefully read all properties and all type of notes also important. Thorough aware on these things. Clear? Remember, every polynomial is a continuous for everything. Next question. So in our problem, option number 4. See the question number 29. The function f of x is equal to 4 minus x square divided by 4x minus x cube is discontinuous at only one point, means number of points also. Discontinuous at exactly 2 points, discontinuous at exactly 3 points, none of these like this given. Okay, we have to take the function 4 minus x square divided by 4x minus x square. I can write this function 4 minus x square divided by x common x into 4 minus x square. Also I would have write 4 minus x square divided by x into 2 plus x into 2 minus x. Okay? If denominator, this is a polynomial function. It is a polynomial, it is a polynomial function. He does not provide any condition. So it is a discontinuous if x equal to 0, because undefined. 1 by 0 is undefined. So this function is discontinuous at one point is x equal to 0. If I take x is equal to minus 2, also it is discontinuous. Okay, if I take x is equal to plus 2, also it is discontinuous. So at what points it is discontinuous? It is discontinuous at 0, at minus 2 and at 2. How many number of points of discontinuity? So number of points of discontinuity is equal to 3. So option number 3 is the correct. So number of, it is discontinuous at exactly 3 points. Okay, don't cancel them. Where the function is not defined. The function is not defined at x equal to 0, at x equal to minus 2, at x equal to 2, and it is discontinuous. Where it is not defined, that is discontinuous. Next question. See the problem number 30. What is the 30th one? The function f of x is equal to discontinuous plus set. Already I have given this one. Graph we know very well. So mainly graphs we have to learn, very useful to solve the questions, all topics. 0, pi by 2, pi, let us take like this. Okay, minus pi by 2, minus pi. So what is the tan? What is the cot 90? Cot 90 is 0. Correct? Cot 0 undefined. Cot 180 undefined. So graph is like this. It passes through pi by 2. It doesn't pass through horizontal. Tan x passes through horizontal. This is also same. Okay. So where it is defined? It is defined at all multiples of pi by 20 only, but it is not defined at multiples of pi. Tan is not defined at multiples of pi by 2. So it is not defined at x is equal to multiples of pi is not defined. Is not defined. So what do you say that discontinuous? Where it is discontinuous, the function is discontinuous at all multiples of pi. So might be answer is n pi. Tan x is not defined at all multiples of pi. Tan x is discontinuous at these points. It is not defined. Where it is defined, where it is not defined in point. So cot x graph is not defined at multiples of pi. Tan x is not defined at multiples of pi. So these are right. Then it is a continuous. So r minus it is continuous. R minus n pi when n belongs to j. And the domain only is defined. Okay. Next problem. Problem number 31 here. F of x is equal to x square into sin of 1 divided by x, where x not equal to 0. Then the value of the function f at x equal to 0, so that the function is continuous at x equal to 0. So is it a continuous? Then what is asking here? Where it is continuous here? None of these here. So what is the f of 0 here? Function is continuous at x equal to 0. F of 0 is, can you find out here? So f of 0 is equal to limit of continuous meaning f of x as x approaches to 0. Okay, this is equal to limit of f of x value. Find out f of 0 meaning here if it is a continuous. Since according to problem f is continuous at x equal to 0. The f of x value is x square into sin of 1 divided by x as x tends to 0. I have to use property. This can also I write limit of x square as x approaches to 0 into limit of sin of 1 divided by x as x approaches to 0. Now you should apply the limit. This is equal to 0 square 0 into sin of 1 by x. It is not defined. So this is always a finite quantity. So 0 into finite. Why? Because we know that minus 1 less than or equal to sin of 1 by x is always less than or equal to 1. We don't know value, but it is like it lies between minus 1 and plus 1. Minus 1 to plus 1, it is always boundary only. Boundary means it is a finite number. So 0 into finite number, this is equal to 0. 0 into finite number always will be 0. Hence it is f of 0 is equal to what? 0 is the answer. So first option. Okay, very easy to solve the question. Already it is a continuous. Find f of 0 here. You don't, so many people here they made mistake. Don't do that. So this is the oscillate between, it lies between maximum value is 1, minimum is -1. So it is a finite number. It is boundary value. So finite number it is. So 0 into finite number always 0. Next question. See the problem number 32. F of x is equal to mx plus 1 when x is less than or equal to pi by 2. Sin of x plus n when x is more than pi by 2 is continuous at x equal to pi by 2. Then what is the satisfying relation? Okay, so we have to find out. Breaking conditions are given means we should find the left hand limit, right hand limit. At x is equal to pi by 2, what is the f of pi by 2 value? F of pi by 2 is equal to, plus equality condition, here only there, m into pi by 2 plus 1. m into pi by 2 plus 1. Next we have to find left hand limit, LH here. Limit of f of x as x approaches to pi by 2 negative, more less than pi by 2 values. This is equal to limit of f of pi by 2 minus h as h tends to 0. I change like this. When x is smaller than pi by 2, x is smaller than pi by 2, f of x is mx plus 1. Substitute this value. Limit of m into pi by 2 minus h plus 1 as h tends to 0. Now apply the limit. This is equal to m pi by 2 minus 0 becomes here m pi by 2 plus 1. This is the left hand limit. As well as we have to find right hand limit. Limit of f of x as x approaches to pi by 2 plus. This is equal to limit of f of pi by 2 plus h as h approaches to 0. When x is more than pi by 2, the function is sin x plus n. So substitute that. This is equal to limit of sin of pi by 2 plus h plus n as h tends to 0. Now you apply the limit. This becomes sin of pi by 2 plus 0, that is sin pi by 2 plus n. We know that sin 90 is equal to 1 plus n. Since f is what? It is a continuous at x equal to pi by 2. Here I am writing, since f is continuous and x is equal to pi by 2. This means left hand limit is equal to right hand limit is equal to f of pi by 2. So what is the f of left hand limit? Left hand limit we got m into pi by 2 plus 1, m pi by 2 plus 1. Right hand limit 1 plus n is equal to m pi by 2 plus 1. Now equating any two terms. So any two different numbers. So I am equating these two numbers. M pi by 2 plus 1 equals 1 plus n. Both sides 1 cancel. So n is equal to m pi by 2 n is equal to m pi by 2 is the answer. So check up your answers. First option is m equal to 1, n equal to 0, not correct. Option number 2, m is equal to n pi by 2 plus 1, we did not get. We get n is equal to m pi by 2, that is option number 3 then. Very easy to find. Clear? Okay, you should practice like these questions. Very easy to solve the problems. I also practice these things. We can solve this. You can easily solve. You refer the textbooks, so the different textbooks are there. You can easily get answers. So throughout it, continually procedure. This is only. See the next question. F of x is equal to sin x by f of x is equal to sin of pi x. Sin of pi x divided by 5x when x not equal to 0, k when x is equal to 0. If f of x is continuous at x equal to 0, then the value of k is. So at x equal to 0, we have to find this value. At x is equal to 0, f of 0 is equal to k given. Limit find out directly. Limit of f of x as x approaches to 0. This is limit of what is f of x? Sin of pi x divided by 5x as x approaches to 0. This is equal to limit of sin of pi x divided by x, 1 divided by 5 taking outside, as x approaches to 0. We know the property, limit of sin nx by x is equal to n. So this is equal to pi divided by 5. Since f is continuous, therefore f is continuous at x is equal to 0. That means limit of a function, that is pi by 5, is equal to f of 0. F of 0 is k, limit of a function is pi by 5. So what is the answer? First one is correct. Okay, very easy to solve the problem. This is. Without doing also directly, that is the next value, n is the pi. 5 already denominator, that is pi by 5 is the answer. Should try like this next one. Next problem number 34. If f of x is equal to 1 minus cos x divided by x when x is not equal to 0, k when x is equal to 0 is continuous at x equal to 0, then k is equal to 1. Same word problem, at x is equal to 0, f of 0 is equal to k. Limit only find out. Limit of f of x as x approaches to 0, this is equal to limit of 1 minus cos x divided by x as x approaches to 0. Okay, without conversion also we can do it. I said very clearly, shortcut method using a loss model. Observe that if you apply the limit 1 minus cos 0, cos 0 is 1, 1 minus 1, 0 by 0. So this is 0 by 0 form, idea. This is called indeterminate form. that is sin x divided by x derivative 1. Differentiate numerator and denominator separately. 1 derivative 0 minus cos x derivative minus sin x becomes plus upon x derivative 1. Now if you apply the limit, sin 0 is 0. Okay. Now since f is what? Continuous. Since f is continuous at x is equal to 0. This means f of 0 is equal to, that is equal to limit of a function, limit of f of x approaches to 0, that is k equal to, k is equal to 0 here. Are you okay? So every question we are doing that, it's very easy to find the k value whatever you want. See, different questions only there. Variety functions are given, only model will be same. Next problem. See the next question. So here using a last model only we do. Very easy that is. What is the last model? Differentiating numerator and denominator separately until the get finite value. So next question. F of x is equal to sin of 5x divided by x square plus 2x when x not equal to 0. When x is equal to 0, f of x equal to k plus 1 by 2. Okay. So now we have to check at x is equal to 0. At x equal to 0, what is the f of 0 value? K plus 1 divided by 2. Now we are finding limit of a function at x equal to 0. What is the value of k? Almost all similar question. So find the limit of f of x as x approaches to 0. This is equal to limit of, what is the f of x? Sin of 5x divided by x square plus 2x as x approaches to 0. Okay. So directly also we can do it without using a L'Hospital rule. Limit of sin of 5x divided by, I take x common, x plus 2 as x approaches to 0. So this is equal to, I can separate this value. How do I separate? Limit of sin of 5x divided by x as x approaches to 0 into limit of 1 divided by x plus 2 as x approaches to 0. Limit of 1 divided by x plus 2 as x approaches to 0. Now do you know this value? Limit of sin x by x as x approaches to 0 is equal to n. So this is equal to, I am writing here 5 into, apply the limit 1 divided by 0 plus 2, 1 divided by 2. So 5 into 1 by 2. This is equal to 5 divided by 2. I got limit of a function is equal to 5 divided by 2. Since f is continuous, here I am writing since f is continuous at x is equal to 0. That means f of 0 is equal to limit of f of x as x approaches to 0. F of 0 is equal to limit of f of x as x approaches to 0. What is the f of 0? F of 0 is equal to k plus 1 divided by 2 equals, what is the limit of the function? 5 divided by 2. Simplifying, k is equal to 5 divided by 2 minus Are you okay? So like we have to solve the question.